Now this is a classic question. Which out of ammonia and NF3 has greater dipole moment and why? Ammonia has a much greater dipole moment as compared to NF3, which has a significantly lesser dipole moment. Wow, is that the case? Yes, that is the case. Why? Well, let me tell you why. Actually, this looks contradictory. Why? Because nitrogen has electronegativity of 3, roughly, and hydrogen has around 2.1 or 2.2. So the difference between NH in electronegativity is just around 0.8 or 0.9, while the difference between nitrogen and fluorine, nitrogen is 3, fluorine is 4, difference is 1 unit. So NF3 might have been expected to be more polar, but NF3 is much less, and the answer lies in their geometry. Come, take a look. Let's draw both NH3 as well as NF3. I have N, a lone pair, H, H, and H. It's a trigonal pyramidal structure or NH3. Similarly, let me draw NF3. NF3 also has a very, very similar looking structure. But there is a crucial difference. Are you aware that the lone pair also has a very significant dipole moment? What? Yes. And dipole moment is a vector quantity. What does that mean? It means that, see, this is the dipole moment, the direction of dipole moment of lone pair. And nitrogen has delta minus, hydrogens have delta plus. Hence, the dipole moment of this bond, of this bond, of this bond, you have 1, you have 2, and you have 3, like this coming up. This is the molecule, like, just imagine. Ammonia. So 1, 2, and 3. So do you see 1 is in this direction, 2 in this direction, 3 in this direction. So their horizontal components will cancel, but the vertical component will add up. So overall, if you just combine these 3 hydrogen atoms, you will find that they have an overall dipole moment in upwards direction. So 3 NH bonds add up to give you an upward dipole moment. And lone pair also has a dipole moment upwards. So these dipole moments add up. So the dipole moments of NH bonds and that of lone pair add up to give you a significantly high dipole moment of ammonia. Is that not the case for NF3? No. Why? Just look. This lone pair has a dipole. This is the direction of dipole moment of the lone pair. And what about N? Fluorines are most electronegative. So they have delta minus and nitrogen has delta plus charge. Because of that, this is the direction of dipole moment of NF3. So since these dipole moments are moving away, their net sum would be, their horizontal components will cancel, but net vertical component would be there. And that would be downwards. Lone pair has a dipole moment pointing upwards. NF bonds have a dipole moment pointing downwards. They cancel. Oh my God, yes. And because they cancel out, you find that the dipole moment of NF3 is significantly reduced. It is much lesser, it is much less polar as compared to ammonia, in which case the dipole moments happen to add. So you can see that simply electronegativity difference between two atoms is not the only criteria for deciding the overall dipole moment of the molecule. The geometry, the lone pairs, everything plays a very important role.